everybody. I'm Savoldi. I just actually graduated with my MN this February, so very recently. And today I'm going to be presenting my thesis, the work I did for my MN, which is this program called Galica. This is a live coding system that I developed. And for those of you who don't know, live coding is this emerging electronic music performance practice in which the performer or live coder typically stands in the front of the room, projects their screen and for the audience to see, and they type code and algorithms that they run real time so that the audience can watch what they're doing and hear the sonic outcome of what they've written. This follows a very extensive history of electronic music practices, and it calls on a lot of themes from those sorts of things. But the exciting thing about live coding is that anything that you can imagine, that you can turn into code, you can create. And so in a certain kind of way, the live coder is really creating their instrument during the performance and changing it in ways that are sometimes even surprising to themselves. So lots of these systems currently exist. The exciting thing about Galica is that not only are you restrained to the code box, but also you can use a MIDI controller like this one to interact with the algorithms that you're creating. And the idea behind this is to try to recruit some of the really powerful benefits of using physical interaction with the system. So it's no mistake that many music practices, like acoustic music practices, involve physical manipulation of some kind of interface. And that's because there's a really strong coordination between the brain and what you're physically doing, in terms of muscle memory and embodied cognition. And so even though conceptualizing the music you're creating as algorithms is very powerful, there's this other sort of mode of performance that is oftentimes kind of neglected in live coding. And so that's what the goal of this system is. And I'm hoping to be able to demonstrate this with a demo that hopefully everything will go well. And I'll try to not make it too technical, and we'll see how that goes. Apologies in advance. So I'm just going to go through line by line. If I were actually doing a live coding performance, we would start off with a totally blank code box typically, and I would be creating everything on the fly. But for the sake of time, I'm just going to use a predetermined little routine that I created. And so the first thing I'm going to do is create a sequencer. So that's what this line is doing, creating a sequencer object. And a sequencer is a concept that's very familiar to people who use hardware, synthesizers, Eurorack sorts of performances. All it really does is it says, I'm going to plan for this sonic event to happen at this time. So I'm going to start and say, I have this melody, right? These are scale degrees. And I'm going to say every quarter note, or I'll do every half note, play one of these notes. There we go, it's good. So yep, it's just stepping through each of these notes on every time interval, just on some set tempo. And then I can make it a little more complicated and add some rhythmic variation. And the cool thing about this is that I created this melody, but I actually I wasn't totally sure what it was going to sound like because there's 4 notes and then there's 3 durations. So the actual combined melody is longer than either the 4 or the 3 that I've created. Another cool thing about the Galica sequencer is that it is highly modifiable. And this is in part to help with using the MIDI incorporation, but it's also just a very powerful tool in itself. So one of these is a callback, which happens on every step. So what I've done here is I've said this last note in this melody, I'm going to randomly change it to make it higher or lower sometimes. So when I write this, now it's randomly changing what the melody is sounding like. And me, the live coder, can just kind of step back and watch this process happen. And here I'm going to do something similar. I'm going to say all the rest of the notes. If 30% of the time, it's going to randomly change them. So to first display how we can kind of use a MIDI controller to interact with this, I'm going to change the amount that it is that the note will randomly be increased or decreased by using a dial on my MIDI controller. So I'm going to say this CC dial, which is 16, is going to correspond to how much the note changes. So you should be able to hear that it changes more as I increase it, and I can make it go back to not changing it at all. So this might seem kind of trivial, but it's really cool because I'm actually taking this algorithm that I've set in the code, and now I can step away from my keyboard, and it doesn't have to be a MIDI controller like this, it can be anything. I can start interacting with the way that it sounds without even having to touch the keyboard. And so this is exciting for the performer to get to form these associations with it, and also for the audience to be able to see something beyond just somebody hunched over a big computer. And just to add a little more variability, you can make multiple sequencers. So this one is going to be a drum sound, as you can hear a little bit. And I'm going to show you, you can also use an algorithm like this one to adjust the volume of the drum. And another cool thing is, typically when we think about sequencers, we imagine them to be sequencing notes, like the ones I've shown you do. But that doesn't have to be the case. And in fact, in typical hardware sequencers, it's very common for you can just patch, pull a wire from one module to another. It can sequence anything you want. And that is also true for Galica sequencers. So this sequencer down here is actually going to sequence the volume of my melodic sequencer. So you can hear it start to make it louder and softer over time. And the last thing that I want to show from this is this feature where I can actually change the mapping of this value. If you see here, I have these selected algorithms and available algorithms on the right side. And so I've said anytime that A appears in the code, I want it to represent this algorithm. And so if I replace this with A, this is now going to respond to the algorithm that I'm moving with the dial. And so in this way, you're able to create even bigger, and again, as the performer, I'm not always entirely sure how moving the dial is going to change the sound. But the cool thing is that I don't need to know. I don't need to know exactly what the algorithm is doing. And in fact, I don't even need to think about the algorithm. As I'm moving the dial, I can just hear the sounds as they're changing and actually play the instrument that I've created for you. Yeah, and so you can do this with multiple algorithms, putting them in the code, and play the live code in a way that is previously uneasy. I think that's all I have. Thank you very much.